So the question says, the diagram below, not drawn to scale, shows an open cylindrical container made of metal with a cylindrical base and uniform thickness throughout. It says the length of the container from the top to the outer bottom is 120 centimeter, and the inner and outer radii are 12 centimeter and 15 centimeters respectively. We're to take pi to be equal to 22/7, and A is asking us to draw a cross-sectional view of the container showing the measurements of the inner and outer radii. All right, this is not supposed to be difficult. Cross-section means simply this. It's like you take a knife and cut the container like that. And I think I gave this definition when I taught this topic. Cross-section is the surface of a solid that is exposed when it is cut. Cross-section is the surface of a solid that is exposed when it is cut. So it's like somebody cut the solid like that, and the surface that is exposed is called the cross-section. All right. So let's get going with the cross-section. It's a very simple thing. What you're going to do is you're going to draw two concentric circles. The word concentric simply means that they have the same center. All right, that's not doing such a great job. So I have my two concentric circle. This is the center. This is the inner radii, which is 14 centimeters. And this is the outer radii, center O, the outer radii, which is 15 centimeters. All right, the diagram you have, is it looking something like this? Anybody? The cross section that you have, is it something looking like this? Anybody? Nobody now talk. Anyway, this is what the examiner expects you to draw. Now let's have a look at the second part of the question. In the second part of the question, we're asked to show that the capacity of the container is 73,304 centimeters cubed. Now, capacity is just another way of saying volume. Or you can say the capacity of the container is the amount of space in the container. Space is volume. The definition of volume is that volume is the amount of space a body occupies. Now, since the cylinder, so in other words, if you're after the capacity of a container, which is the amount of space, which is the amount of space or capacity, is the amount of available space in the container. And space is volume, and the container is a cylinder. The volume, let me change the word to capacity. The capacity is equal to what? A times H. I know sometimes I have a problem. I'm a perfectionist, you know. Capacity, which is volume, is equal to A times H, where A is the area of the cross section and H is the height. Now, since what you're now the shape is a cylinder, which is a solid shape with a uniform circular cross section. So A here is a circle. So this would be equal to pi r square h. Now, can everybody agree that the thickness of the container is 1 centimeter? Can everybody agree that the thickness of the container is 1 centimeter? I'm asking a question. Anybody? Well,
Sir,
actually,
so
I'm
I
on
get
my
the one
own.
system to my.
The thickness of the container is 1 centimeter. Why? The inner radii is 14 and the outer radii is what? 17. From the center to the outer border is 15. From the center to the inner border is what? 14. So the thickness of the container is 1 centimeter. Now, since I'm measuring capacity, which is the amount of space inside the container, the radius I must use is 14. So pi is what? 22 over 7 times 14 over 1 times 14 over 1 times the height. Who can tell me what is the height of the container that I should use to calculate the capacity of the container? Anybody?
Sorry, I could cross multiply the 7 from the 14. I could get
No, that's not cross multiply, that's canceling. What I
cancel.
want to know is what is the height? Somebody tell me what is the height? The radius of the radius that I'm using when calculating the capacity is 14. Who can tell me what is the height of the container? Ladies and gentlemen, the height is 119. Now, why am I using 119 and not 120? Anybody? Why am I using 119 and not 120? Anybody? All right. Crowd is killing me. Listen to this is 2. So the answer here is 22 times 2 times 14 times 119. And this is 73,304 centimeters cubed. We're asked to show that, and that is what we just did. The reason we use 119, the capacity is measuring the space inside of the cylinder, and the height of the space inside the cylinder is 119 because the thickness of the base is 1 centimeter. So let's have a look at C.
Sir.
No. Yes.
I get the 119.
The outer. See here? The outer height is 120. The base is 1 centimeter thick. So the inside from here to here, that is 119 centimeters.
Oh, okay then.
All right. Now we're asked to determine the volume of the material used to make the container. Now, let's have a look at the container. Now, this container is not a solid container. The idea of this container is as if you started out with a cylindrical block and then a cylinder was scooped out. A cylinder was scooped out of it. So if I want to determine the volume of the material, I must find the outer volume and then subtract the inner volume. And what will be left is the volume of the material. Now, so the inner volume we already know. The inner volume we already know. What we need now to do is to find the outer volume. So let's say outer volume. The outer volume is what? Pi r square h, because the outer shape is still a cylinder. This is 22 over 7 times 15 times 15. the outer radius is 15, and the outer height is 120. So let's work this out. You're going to multiply the 22 by 15 by 15, multiply by 120, and you're going to divide all of that by 7. Ladies and gentlemen, the outer volume would be 84,857 centimeters cubed. That's the outer volume. Now, if I want to get the volume of the material, it would be the outer volume, which is 84,857, minus the inner volume, which is 73304. 73304. All right, and this comes out to be, so it's 84,857 minus 73304. This is 11,553 centimeters cubed. All right. Now, the inner volume is equal to the capacity. So all I did for the outer volume, then take away the inner volume, and what will be left is the volume of the material. The last part of the question, we're asked, given that the density of the material used to make the container is 2.2 grams per centimeters cube, we're asked to determine the mass in kilogram of the empty container. Now, here's what we know. We know that density, the symbol for density is rho, is equal to mass over volume. If you didn't know that, it's not important. You could have just put the word density. Now, mass is what we want to find. So what I can do is I can I write my formula, I can put in what I know. The density is what? 2.2. The mass I don't know over the volume of the container, which is 11,553. So what I did is I wrote the formula, put in what I know. Now I'm going to work to find what I don't know. If I have one fraction is equal to one fraction, what I should do is I should cross multiply. So 1 times m is equal to 2.2 times 11,553. So 11,553 multiplied by 2.2, and this is equal to
25,460.6.
400 and let us see 417, and this is grams. Why grams? Because the density is grams per centimeters cubed. So the mass must be in grams. But the examiner says that he wants the answer in what? In kilometer. Now it is 1,000 grams, in kilograms. It is 1,000 grams that equal to a kilogram. Therefore, the mass would be equal to 25,417 divided by 1,000. The answer is approximately, 25.4 kilograms. The answer is approximately 25.4 kilograms.